Welcome to Prism Science Academy classes, and in this video we are about to start. This is the set 3 of 2024, and we are going to solve the physics part in this. Okay, so the first question says that phenomena of light involved in the formation of a rainbow in the sky are. कौन-कौन से phenomena involved हैं in the formation of a rainbow in the sky? And we know that the rainbow is formed by the tiny water droplets. So ये tiny water droplets हैं, they act as prisms. और इसमें कौन कौन से phenomena involved हैं? तो सबसे पहले जो white light है that enters into the tiny water droplet, और यहाँ पे होती है dispersion. सबसे पहले होगी dispersion. So this white light gets split up into 7 colors. इसके बनेंगे 7 colors: violet, indigo, blue, green, yellow, orange and red. So ये यहाँ पे हो रही है, सबसे पहले हो रही है dispersion. उसके बाद डिस्पर्जन होने के बाद यही लाइट वापस टाइनी वाटर ड्रॉपलेट में ही रिफ्लेक्ट करेगी अंदर ही. तो हम इसे बोलते हैं टोटल इंटरनल रिफ्लेक्शन. सो ये है पॉइंट बी जहाँ पे हो रही है टोटल इंटरनल रिफ्लेक्शन. और टोटल इंटरनल रिफ्लेक्शन होने के बाद लाइट जब ये 7 कलर्स they come out of the water droplet and they are now refracted because they are coming from the optical denser to the rarer medium. So point C पे हो रही है refraction. तो हमारे पास refraction, dispersion और total internal reflection की दो choices हैं, लेकिन इनमें जो correct order है वो है dispersion, फिर उसके बाद होती है आपकी total internal reflection और फिर होती है refraction. तो refraction, dispersion and total internal reflection. तो इसमें जो हम order ले सकते हैं that is the D. So D should be the correct order क्योंकि पहले होती है dispersion, फिर होती है total internal reflection और फिर होती है refraction. So D is the correct option in this case. For question number 14 में दिया है in case of 4 wires of same material. So same material है, इसका मतलब resistivity is same. और resistance minimum will be minimum if the diameter and length of the wire respectively are. अब इस केस में हमें पता है रेजिस्टेंस है वो डायरेक्टली प्रोपोर्शनल होती है लेंथ को, और रेजिस्टेंस इनवर्सली प्रोपोर्शनल होती है एरिया ऑफ क्रॉस सेक्शन को. और इन दोनों को अगर कंबाइन करें तो रेजिस्टेंस इज प्रोपोर्शनल टू आएगी L बाय A. और प्रोपोर्शनल का साइन हटाएंगे तो यहाँ एक कांस्टेंट ऑफ प्रोपोर्शनलिटी आएगा जिसे हम रेजिस्टिविटी बोलते हैं. तो रेजिस्टेंस का फॉर्मूला होता है R इज इक्वल टू रो इंटू L बाय A. और जो A है वो होता है एरिया ऑफ क्रॉस सेक्शन वेयर R इज द रेडियस ऑफ द वायर, और रेडियस ऑफ द वायर होती है डायमीटर का हाफ. तो एरिया ऑफ क्रॉस सेक्शन को हम लिख सकते हैं पाई डी स्क्वायर बाय 4, और लिख सकते हैं 4 पाई डी स्क्वायर. सॉरी, तो ये बन जाएगा आपका, यहाँ पे लिख सकते हैं हम रो एल, area of cross section will be now pi d square by 4, and now this resistance in terms of diameter अगर हमें लिखनी तो ये बन जाएगी 4 into rho into L upon pi d square. Okay. अब first case, let's consider the first case. और पहले केस में दिया है आपकी डायमीटर है d by 2 हाफ हो गई है, और लेंथ भी आपकी 1/4 हो गई है. तो let's use this formula. तो रेजिस्टेंस इन ए केस, तो ये हो जाएगा 4 इंटू रो इंटू एल हो गई है L बाय 4, और डायमीटर हो जाएगा पाई इंटू डायमीटर है हाफ डी स्क्वायर. So this is now equal to pi into this is rho L by 4 upon pi into d square by 4. 4 और 4 we can cancel that out. So इसका मतलब है इसमें रेजिस्टेंस जो है वो 4 into rho into L by pi d square ही है. So This was the resistance R. इसका मतलब इस केस में रेजिस्टेंस उतनी ही रहेगी, there will be no change in the resistance, क्योंकि 4 into rho L by pi d square is R. Okay, but we have to find that the case where the resistance is minimum. Let's consider the B case. In B case, diameter is one fourth, and okay, यहाँ पे length है 4 times the original length, और diameter is d4. और इस केस में अगर हम रेजिस्टेंस फाइंड आउट करें बी केस में, तो फॉर्मूला है 4 इंटू रो इंटू लेंथ हो गई है 4 टाइम्स एल पाई, और डी हो गया है डी बाय 4 द होल स्क्वायर. So this is 4 into rho into 4L upon pi into d square by 16. So ये बन जाएगा, this is now RB is equal to 4 into, this becomes this 6 is now 64. So 64 rho L by pi d square. I can write it as 64 into 4 into rho into L by pi d square, और ये है आपकी रेजिस्टेंस. तो इस केस में रेजिस्टेंस बढ़ गई है, ये 64 टाइम्स द ओरिजिनल रेजिस्टेंस हो गई है. और सेकंड केस में तो कोई चेंज नहीं था. लेट्स कंसीडर द थर्ड केस. जो थर्ड केस है उसमें आपकी डायमीटर है 2d और लेंथ हो जाएगी L. तो रेजिस्टेंस इन थर्ड केस हो जाएगी 4 इंटू रो इंटू L अपॉन पाई. अब d जो है वो है 2d द होल स्क्वायर. सो दिस बिकम्स 4 इंटू रो इंटू L अपॉन पाई इंटू 4d स्क्वायर. अब इसे मैं लिख सकता हूँ, दिस 1/4 आई कैन टेक आउट. So 1/4 into 4 into rho into L upon pi d squared. So ये हो जाएगी 1/4 of the resistance. So इस केस में हो रही है 1/4 of the resistance. तो अभी तक जितने भी केसेस हैं सभी में मिनिमम C केस में. लेट्स कंसीडर द D केस. D केस में डायमीटर है 4 टाइम्स और लेंथ है 12. So D केस में डायमीटर है 4 टाइम्स और लेंथ है 12. Okay, so let's use the formula. So resistance in D case is 4 into rho into L हो गई है 12 by D हो गया है 4D the whole square. तो ये बन जाएगा, this is now 4 into rho into 2L upon pi, this is 16 D square. So resistance in this case, I can write it as, this is 8. So this is 1 by 8 into rho L by pi d square. 4 into. So in this case, resistance is 1/8 of the original resistance. So this is the minimum resistance. So that means in सभी cases में से जो minimum resistance है, that is obviously in the case D. So D is the correct answer. और इसमें diameter जो है सबसे बड़ी है, तो resistance will be minimum in this case. And if you want to check, you can check by converting area of cross section को in terms of diameter लिख लो and just replace the values. You will get to see that the resistance is minimum when diameter is 4 times the original diameter and length is double. Okay, for question number 19, which is assertion in the reason-based question, it's given that the red light signals are used to stop the vehicles on the road, which is true. Now, why it is used? Because the reason given is red color light is scattered the most so as to visible from a large distance. It's false. It's not scattered the most, but it's scattered the least, so that it remains at the spot. ताकि वो एक spot पे रहे और हमें we can easily see it from a large distance. So our options would be A is true and reason R is false. So which gives us the option C to choose. So for this, the correct option is option C. Okay, for question number 24, it's asked, when do we say that a particular person is suffering from hypermetropia? So for this question, hypermetropia means farsightedness, and farsightedness means that he is not able to see the nearby objects clearly, distinctly, but can see the far away objects clearly. So it's also called farsightedness. And when do we say? So पूछा गया है, हम कब बोलेंगे that a particular person is suffering from hypermetropia? And the reason for that is when he cannot see nearby objects distinctly. So I can write answer for this will be when he cannot see nearby objects distinctly. Distinctly means he can see them, but not distinctly. He cannot make sure whether objects are clear enough or not. So when he cannot see objects distinctly, but he's able to see, can see the far away objects clearly, but can see far away objects clearly. And two causes of this defect. So causes or the reasons for this are the focal length of the eye lens is too long, has increased. So the reason for this is that focal length so focal length of eye lens is increased, or we can say that हम ये भी बोल सकते हैं कि eyeball has become too small. Next देखो. Okay, name the type of lens used to correct this defect. So type of lens used to correct this lens is the convex or converging lens. So convex or converging lens. Convex lens is also called converging lens. So this type of lens is used to correct hypermetropia. So this is exactly you have to write your answer. Okay, for the next question, it's given. It's asked to draw a label diagram to show the pattern of magnetic field lines produced due to a current carrying straight conductor. And we have to mark on it the direction of current in the conductor and the direction of magnetic field lines. Now, let's say this is a current carrying straight conductor. Okay, ये है एक करंट कैरिंग स्ट्रेट कंडक्टर और इसे कनेक्ट करते हैं हम. Let's connect this with a battery. Let's connect this with a battery. Okay, let this be a battery, and this is connected to the conductor using the connecting wires. Let this be the key. So we have to draw a well-labeled diagram. That is, let's make sure that we have the components as well. So this is the battery with the positive and the negative terminal, and this be connected to the conductor. Okay, let there be a ammeter here. यहाँ बनाएंगे एक ammeter, and positive terminal of the ammeter is connected to the positive terminal of the battery, and let there be also a variable resistance here. Let this be a variable resistance rheostat, ओके, ये कनेक्ट कर दिया हमने स्ट्रेट करंट कैरिंग कंडक्टर। स्ट्रेट करंट कैरिंग कंडक्टर है हमारा एक्स वाई। नाउ क्वेश्चन में दिया गया है वी हैव टू मार्क ऑन इट द डायरेक्शन ऑफ करंट। सो डायरेक्शन ऑफ करंट इज फ्रॉम द पॉजिटिव, सो इन डायरेक्शन इज current is flowing in this direction, so this is the direction of the current in the conductor in the downward direction. And now we have to mark the direction of magnetic field lines. So magnetic field lines would be in the form of concentric circles produced around a straight current carrying conductor. So these are the magnetic field lines in the form of the concentric circles. So these are the magnetic field lines. और हम बना लेते हैं इन magnetic field lines को एक, let there be a cardboard to get this the magnetic field of lines. Okay, now we have to show the direction of the magnetic field lines. The magnetic field lines की जो direction है, these can be either anti-clockwise or clockwise. This is the direction of the current. And to find the direction of magnetic field lines, let's use the right hand thumb rule. Our right hand thumb rule says that if we grasp the conductor in our right hand and if the thumb shows the direction of the current, then the fingers direction with the fingers curves gives the direction of the magnetic field lines. So if we apply the right hand thumb rule, the direction of the magnetic field lines will be, in this case, the direction of magnetic field lines if we use the right hand thumb rule. So the current is coming down in the current in this conductor, so it's coming down, so the direction of magnetic field lines will be given by the direction in which the fingers curl. So the fingers are curling in, if this is a horizontal sheet of paper, then the fingers are curling in this direction. So this is the direction of magnetic field lines in the upward direction. Okay, and let's label it as these are the magnetic field lines. So if we consider this to be a horizontal sheet of paper, then the direction of magnetic field lines would be anti-clockwise. So these are the direction of the magnetic field lines. Okay, for question number 25th, part B, we have to name the device used to magnetize a piece of magnetic material, and the device used to magnetize a piece of magnetic material can be, it can be permanent magnet. You can use the permanent magnet to magnetize a piece of magnetic material. There is a process, or you can use a solenoid, or either you can use the electromagnet. So this is the device. Now we have to draw a label diagram to show the arrangement used for magnetization of a cylinder made of soft iron. For that we are going to use the solenoid, and solenoid is a closely wrapped insulated copper wire in the form of a cylinder. So this is a closely wrapped insulated copper wire in the form of a cylinder. And to magnetize a cylinder made of soft iron, we are going to insert that soft iron inside the solenoid. So this be soft iron inserted inside the solenoid, and we are going to pass the current in it. So the current is, let's attach a battery connected to the battery, and let's also draw a close key. Okay, so this is negative positive, so current is going to flow in this direction. So, so current is coming in these curves and going in this direction. Okay, now let's label it. This is the iron rod, and this is a current carrying solenoid. So this is a label diagram to show the arrangement used for the magnetization of cylinder made of soft iron, and the device used we have used here is solenoid. So this was for question number 25, part B. Okay, for question number 31, we have to name and explain the phenomenon of light due to which path of beam of light becomes visible when it enters a smoke-filled room through a small hole. तो हमें वो फिनोमिना का नाम और उसे एक्सप्लेन करना है जिसकी वजह से लाइट का पाथ दिखना शुरू हो जाता है जब वो एक स्मोक फिल्ड रूम में किसी होल के थ्रू एंटर करती है, और उस फिनोमिना का नाम है Tyndall effect, and that is because of the scattering of light. Now we have to explain this phenomena. So in this case, we can write that when a beam of light, so the name of the phenomena is Tyndall effect, and it says that when when a beam of light, it strikes the particles of smoke or the fine particles of smoke. When a beam of light strikes fine particles of smoke, it is reflected diffusely. Diffusely means in all directions. It is reflected diffusely, and hence the path of light becomes visible. Okay. Also, it asks also state the dependence of color of light we receive on the size of the part of the medium through which the beam of light passes. Means कौन से colors, कौन से particles जिनका size अलग अलग है scatter करेंगे, तो mainly very fine particles जो है जिनका size जो है, the very fine particles जो है वो light of shorter wavelength को scatter करते हैं. So very fine particles, they scatter lights of shorter wavelength. So in this case, we can write that now uh, the scattering of light, it makes the particles visible. So for Tyndall effect, we can, this is called the Tyndall effect. We can also write here the scattering of light. Okay. Now the very fine particles, the color of the scattered light depends on the size of the scattering particles. We can write here that we have to mention here that because it's asked, state the dependence of color of light we receive on size of the particle of the medium. So the color of scattered light, it depends on size of the scattering particles. Now, जो very fine particles हैं, they scatter mainly blue light of shorter wavelength. So very fine particles, I'm going to write which color is scattered by which particles of size. So very fine particles mainly scatter blue light, and while particles of large size particles of large size they scatter light of longer wavelengths. So very fine particles they scatter light mainly scatters a blue light of shorter wavelength, while the if the size of the scattering particle increases, the large size of the scattering particles they scatter light of longer wavelength. That means that on now the very fine particles they scatter light of shorter wavelength. If the particle size is large, they scatter light of longer wavelength. And now if the size of the scattering particles is large enough, then scattered light may even appear white. Now let's say if the size of scattering particles is large enough, the light may appear white as well. Enough, then the scattered light may even appear white. Okay, this is how this has to be answered. Let's move on to next question. Okay, for question number 32, we have to explain in brief the function of an electric fuse in a domestic circuit. So electric fuse is a safety device that is used in the electric circuit, and it prevents the damage to the appliances and the electric circuit from overloading and short circuiting by melting the fuse wire. So we can, the function of the electric fuse, we can say that electric fuse, it's a safety device that prevents the damage to the appliances and the electric circuit from overloading and short circuiting. By melting the fuse wire and hence breaking the circuit. Okay, this was for the first part. Now an electric heater operating 3 kilowatts, so that is the power that is 3 kilowatt, which and 1 kilo is equal to 1000, so this is 3000 watt. And potential difference, it has to be operated on a potential difference of 220 volt. Okay, now there is a fuse rating of 5 ampere and in which this electric heater is operating. So ये electric heater connected है 5 ampere rating के fuse के साथ. So what is likely to happen when the heater is switched on? The heater को switch on करेंगे तो क्या होएगा? So let's calculate the current that will be drawn. So what current will be drawn by this electric heater? So we know that P is equal to V into Y, I is equal to P by V. So potential difference P है आपका 3000 watt, potential difference at 220. This is 11 and 150. So 150 by 11 is 13.63 ampere. So 13.63 ampere का current जो है वो जाएगा सर्किट में, और सर्किट में जो फ्यूज जो है, फ्यूज की रेटिंग है 5 एम्पियर. सो दैट मीन्स द करंट 13.63 एम्पियर is very greater than, we can say, the rating of fuse wire. So this is not bound to be operated on this circuit that has a fuse of 5 amperes. So when this is connected, the fuse wire will melt and break the circuit. So we can say that when heater is connected, a current of 13.63 ampere is drawn by the circuit, and which is greater than the rating of fuse wire. Therefore, fuse wire will melt and break the circuit. Okay. Okay, for our next question, that is question number 33, we have to state Ohm's law, and we have to write the formula for equivalent resistance RB of the parallel combination of three resistors of values R1, R2, and R3. So what is Ohm's law? Ohm's law states that the potential difference across the ends of a conductor is directly proportional. That is, the potential difference across the ends of a given metallic wire in an electric circuit is directly proportional to the current flowing through it. The condition is that temperature remains the same. So we can say that the potential difference, now the potential difference has symbol V. So it has to be written that हम लिखेंगे potential difference V across the ends of a given metallic wire is, and in that too in an electric circuit, is directly proportional the current flowing through it and the condition is that the temperature should be same, provided the physical conditions remaining same, provided its temperature remains same. That is, V is directly proportional to I, and if we remove the proportional sign, there's a constant which is called resistance. So mathematical form of Ohm's law is V is equal to IR. Okay, now we have to write the formula for the equivalent resistance RP of the parallel combination. So what is parallel combination of resistors? So parallel combination of resistors is when the resistor, one end of all resistors is connected to one end of the battery, and one end of all resistors is connected to the other end of the battery. Next देखो, okay, these are the three resistors that are connected in parallel, R1, R2, and R3. And I'm going to take one end of all the resistors से इन सभी का एक end हम कनेक्ट करेंगे बैटरी के एक एंड के साथ, और इन सभी का दूसरा एंड कनेक्ट करेंगे बैटरी के दूसरे एंड के साथ. Okay, now the current is flowing in this direction, and let there be a key. Okay, now we have to find the okay. So इन सभी में करंट जो है वो डिवाइड हो जाएगा सभी का. Let I1 be the current in the R1 resistor, I2 be the current in the R2, and I3 be the current in the this R3 resistor. और potential difference जो है वो that will remain same across all the resistors. Potential difference जो है वो same रहेगी across all the resistors. Okay, so this is how the current flows. So current across R1 is I1, R2 is I2, R3 is I3. Now the net current or the total current in the circuit will be I is equal to I1 plus I2 plus I3. And this is the net current. So we know that according to the Ohm's law, V is equal to IR. So I is equal to V by R. So this I is equal to V by R, and the net resistance of the circuit is RP. So this is RP, distance in parallel. And I1 will be V by R1. Potential difference will remain same for each of these resistors, and the current varies. So this is V by R2 and this is V by R3. Okay, so this is V upon RP is equal to V is common 1 upon R1 plus 1 upon R2 plus 1 upon R3. So this gets cancelled. So that means इसका मतलब है the reciprocal of the resistance of the resistors connected in parallel is equal to the sum of the reciprocal of the individual resistance connected in parallel. This will give us the minimum resistance. Okay, now for B में पूछा गया है we have to find the resistance of the following network of resistors. So these two are connected in parallel. So इनकी resistance हो जाएगी. This will be for these two. The resistance will be R1 plus R2. So resistance in parallel will be 1 by R plus 1 by R. So this is 2 by R. So that means the resistance in parallel is now R by 2. और अब हमारा circuit जो है, this circuit will look like this. This is the X. Okay. For these two इन दो पैरेलल की बन जाएगी हमारी रेजिस्टेंस RP. तो ये है RP रेजिस्टेंस इन पैरेलल हो जाएगा R by 2 और ये है R. Now these two are connected in series. So ये है terminal Y. The net now these two are connected in series. So resistance in now series is equal to R plus R by 2, which is equal to 2R plus R by 2. And this is 3R by 2. So इस सर्किट की जो नेट रेजिस्टेंस है वो लास्ट में सीरीज में है, दैट इज 3R by 2. For next question, we have to draw a ray diagram to show the path of the refracted ray in each of the following cases. And the first case is the ray of light is incident on a concave lens and is parallel to its principal axis. So first, for the first ray diagram, let's say this is concave lens. Let this be the principal axis. This is optical center. Okay, now ray of light is incident parallel to its principal axis. So ray of light is incident parallel and it will be refracted like this. We have to give the directions. but it seems to be ऐसा लगेगा ये this seems to be coming from the first principal focus. So this is the path of the ray diagram, and the ray of light is parallel to the principal axis. So it will be refracted in this direction, but it will seem to be coming from the principal focus. Now the second case, this is the first one, and now for the second case, it's directed towards the principal focus. So in the second case, it has to be directed towards the principal focus. Okay. So now the ray is directed towards the principal focus. Okay, so this is directed towards the principal focus. So it will be reflected and will move parallel along the principal axis. And so this is directed towards the principal focus. Okay, so if this is directed towards the principal focus, it will move parallel along the principal axis. So this is the ray diagram for the first two cases. Now for the second question, a 4 centimeter tall object is placed perpendicular. So this is the second. The height of the object is given by 4 centimeter of a convex lens of focal length, and the sign convention for focal length for is plus, which is 24 centimeter, and distance of the object, which is denoted by u, is given, so which is negative 16. Distance of the object is noted by u and has to be, this is in front of the lens, so we will use sign convention negative. Now we have to find the position and size of the image formed. That is, we have to find out v and we have to find out h dash. Now let's use the lens formula. So this is a convex lens, so we are going to use the lens formula. So using lens formula. So lens formula is 1 upon v minus 1 upon u is equal to 1 upon f. That will give us the image distance from the lens. So 1 upon v, 1 upon u is negative 16, 1 f is 24. Minus minus is plus, so this is 1 plus 1 by 16 is equal to 1 by 24. 1 by v is equal to 1 by 24 minus 1 by 16. LCM of 16 and 24 is, so this is 48. 16 freezer is 48, so LCM is 48. 24 is 2 minus 3, which is negative 1 by 48, and 1 by v is equal to negative 1 by 48, so that means v is equal to negative 48 centimeter. So image is formed in front of the lens at a distance of 48 meter, because negative sign is towards the left side, so image is in front of lens at a distance of 45 centimeter and it's real and inverted. So image is formed on the same side of the object. Now we have to find the size, and we know that M is equal to H dash by H is equal to V by U. So let's use this combination. H dash is the size of the image, H is the size of the object. Size of the object is 4 centimeter, V is minus 48, U is negative 16, so 16 3s is 48, and height of the image is 12 centimeter. So height of the image, we can write that size of image is 12 centimeter. Okay, for next question, we have to draw a ray diagram to show the path of the reflected ray. हमें बनाना है ray diagram. Reflected ray का path show करना है when ray of light incident on a convex mirror is parallel to its principal axis. So let's draw a convex mirror, and the ray of light is coming parallel to the principal axis. So let this be the convex mirror. This is the non-reflecting surface. Let this be the principal axis. This be the pole, and this is a convex mirror. So principal focus lies behind the mirror, and here is the center of curvature. Ray of light coming parallel to the principal axis will be reflected and will be seen to be coming from the principal focus. So this is the path of the ray of light, and it will be seen ऐसा लगेगा ये principal focus में से आ रही है, and this ray is the normal. So this is the normal, and we will use the dotted line to indicate that it's a normal. A normal passes through the center of curvature. ये है angle of incidence, ये है angle of reflection. So this is how the ray of light parallel to the principal axis looks like or goes like the path of the ray of light. Second one is directed towards its principal focus. और second one में इसको डायरेक्ट करेंगे principal focus की तरफ. This is the ray diagram 2. The ray of light is directed towards the principal focus. Okay, now the ray of light now is directed towards the principal focus. And the reflection will take place here. So if it's directed towards the principal focus, it will be reflected parallel to the principal axis. So this is how it will be reflected. This is the normal. Okay, so these are the ray diagrams to show the path of the ray of light, and we can label it as the incident ray and the normal ray. So this is the incident ray, this is the normal, sorry, this is the incident ray, and this is the reflected ray. Here also this is the incident ray and this is the reflected ray and this is the normal. So moving on to the next part, 1.5 centimeter tall candle flame is placed perpendicular to the principal axis of the concave mirror. So here, this is part 2, and height of the object is given by h. So it's 1.5 centimeter tall, and to the principal axis of a concave mirror of focal length. For concave mirror, the focal length is negative, so it's negative 12 centimeter. If the distance of the flame from the pole of the mirror is 18 centimeter. So this is the object distance u is equal to negative 18 centimeter. Use the mirror formula to determine the position and size of the image formed. So we have to find v and h dash. So let's use the mirror formula. And the mirror formula is the relation between the object distance, image distance, so mirror formula is 1 upon v plus 1 upon u is equal to 1 by f. तुम खड़े हो जाओ बेटा, खड़े होके याद करो, खड़े जाओ, ठीक है, नेक्स्ट देखो. 1 upon u is negative 18 is equal to f is negative 12. Okay, so this is 1 upon v, negative 1 by 18 is equal to negative 1 by 12, and 1 by v is equal to negative 1 by 12 plus 1 by 18, LCM of 12, and 18 is 36, so this is negative 3 plus 2. So 1 by v is equal to negative 1 by 36, which gives me v is equal to negative 36 centimeter. So the image is formed. Negative means the distance is in front of the mirror. So image is formed in front of the mirror at a distance of 36 centimeter. Now we have to find the size of the image, and we know that the magnification in this case is h dash by h is equal to negative u by u. So we are going to use this combination. We have to find h dash. So we have to find h dash, that is the size of the image. Height of the object is given 1.5. So 1.5 is equal to negative v is negative 36, and u is negative 18. So this is negative 18. This gets cancelled. We still have negative sign. So h dash is equal to negative 36 into 1.5 by 18, or 18 to the is 36. So h dash is equal to 3 centimeter, which is negative. That shows that the image is inverted and its size is 3 centimeters. So this is the size of the image. So size of image is equal to 3 centimeters. Okay, for question number 39 में दिया है, in a domestic circuit 5 LED bulbs are arranged as shown in the figure. Now the source voltage is 220 volt and the power rating of each bulb is marked in the circuit diagram. So based on the following circuit, so this is the power voltage, this is the source voltage, and there are 4 bulbs connected here. with rating 11 watt and 55 volts. So based on the circuit diagram, we have to answer the following questions. What happens when key K1 is closed? So when key1 is closed, so that means now the current starts flowing in this circuit. So in this circuit, the current starts flowing. This is the continuous path for the current. So that means the bulb A will glow when key K1 is closed. So we can write that bulb A glows in this case. So in this case, you can write bulb A glows. Okay, now for the second part, what will happen when key K2 is closed? When key K2 is closed, now this is the continuous path for the current. This one. Okay. We have to find the continuous and the closed path. So that means B, C, D, and E will glow. So we can write bulbs. So bulbs B, C, D, and E glows. Okay, for B, we have to find the current drawn by the bulb B when it glows. So current drawn by the bulb B when it glows. And so for bulb V, power is given, which is 11 watt. So this is for bulb V. Power is 11 watt and potential difference is 55 volt. And we have to find the current. We know that P is equal to V into I, which gives me I is equal to P by V. P is 11. So this is 11 by 55, which gives me zero point 0.2 ampere. So this is 1 by 5, which gives me zero point 0.2 ampere. So zero point 0.2 ampere is the current when the current drawn by the bulb is zero point 0.2 ampere. So this is drawing a current of zero point 0.2 ampere. So that means these are connected in series. So every bulb will draw a current of zero point 0.2 ampere. Now, C says we have to calculate the resistance of bulb B. So for bulb B, we have current which is 0.2 ampere and potential difference across that for that bulb is 55 volt. And we know that V is equal to I into R. So R is equal to V upon I. So V is 55, I is zero point 0.2, which gives me 550 by 2. This is now 275. So 275 ohm is the resistance of bulb B. Now we have to find the total resistance of four bulbs B, C, and D. So total resistance of bulbs B, C, D, and E. So these are connected in series. So that means these are connected in series. So that means each of them will have resistance 275 plus 275 plus 275 plus 275 because they have same ratings. And the total resistance will be 1100 ohm. Okay, now for the last one, it says what would happen to the glow of all the bulbs in the circuit when K1 and K2 both are closed and the bulb C suddenly fuses. Now both are closed, so that means the current is flowing in both these circuits. But if this one fuses, so that means this circuit is broken. So this one A will keep glowing while B, D, and E will not glow. So we can write bulb A. So bulb A will keep glowing with same brightness, while other bulbs, that is B, D, and E, will not glow. Will stop glowing, and C will also, because it is already fused.